Szarzak, and today I'm going to demonstrate some things about projectile motion. All right, so what this apparatus does is this is spring-loaded, okay, and so when I pull this plunger back, you see this little stem comes out. All right, I have a little metal ball bearing that's got a hole in it. Okay, the reason that I have this here is I can put this on the end. All right, and what this will do is when I trigger this, okay, it just drops the ball and lets it go straight down. Now, remember from last unit, okay, once it's dropped, it's in a state of free fall, so it speeds up at a rate of 9.8 meters per second, or 9.8 meters per second squared down. Okay, so in other words, it just drops the ball. The under the end of this has a little plunger, all right, but this little plunger moves back on top of this platform. So I have a second ball bearing here, okay, that I can place on the platform. And so when I take and I trigger it now, okay, it launches the ball. Now I'm very meticulously set this up so that it's completely level, so that when this ball is launched, okay, it goes completely horizontally. Now what's important about that, okay, is that gravity acts straight down. All right, an important thing about vector components is that if vectors are perpendicular to one another, that's what makes it a component. All right, they are independent of one another. And so when the ball launched moves through the air, its sideways motion maintains a constant velocity, whereas its vertical motion experiences accelerated motion, which just means that it speeds up in the downward direction due to gravity. Right? The idea behind this little demo, okay, is to show what happens when you both launch something simultaneously sideways and drop it straight down. Because gravity is what's causing the acceleration straight down, and because both objects start with an initial vertical velocity of 0, the two will hit the ground at the same time. So watch and listen. All right, pretty neat, huh? The demo that you just saw was for when the launch ball is launched completely horizontally. All right, now I've got my little platform set up at an angle. Okay, and as soon as we introduce an angle, well, now when this ball leaves the platform, it'll be moving both sideways, but it'll also start off with some initial vertical velocity. That changes the scenario, because this one now will have some initial vertical velocity. This will now be in the air for more time because gravity's got to slow it down on the way up and then speed it up on the way down. So let's launch it just so we can confirm this. Let me hear it. Okay, the ball dropped, hit the table before the ball launched upwards at an angle.